Today, we're going to talk all about JavaScript reference versus copy. And I found this to be a sticking point. And while it's not necessarily going to be something that you're going to build that's going to be sweet and your client's going to see it, but this is something that is fundamental to understanding how JavaScript works. And more often than not, this is a source of a lot of bugs because people don't understand what the difference between a reference and a copy is, especially when you get into nested data. So let's take a look at some strings, numbers, and booleans right here. If I have a variable, or let's use let here, and age is set to 100, and then I make another variable called age2 and set that to age. If I console log age and age2, what are we going to get? 100 and 100, right? But what happens if age is equal to 200, and then I also console log age and age2? What are we going to get? Are we going to get 200, 200, or 200, 100? Okay, good. Now we get 200, 100. Why? Because the value of age goes into the variable at the same time. That works the same way with strings. If I do const name or let, I'm going to be reassigning these, so I need to use let Wes and let name 2 is equal to cool. Oh no. Let name 2 is equal to name, console log name, and name 2, you probably will see Wes. But if name is equal to Wesley, and we also console log that, what are we going to get? Wesley West. Okay, good. So the values of strings, numbers, and booleans go into it. And if you change the original one, it's okay. It's not going to update the other one. Makes sense. Now, let's actually work with an array. Let's say we've got some data here, and we want to make a copy of the array. So we say, const team equals players. And that should make sense. Console log players and team, just to make sure we got both of them here. Okay, good. That's the same array here. So you might think that we could do something like this, where we change team 3 is equal to Lux. Now, if I look at team, you'll see Lux is the last one. But if I look at the original one, which is players, what should the last one be? Should it be Poppy as it was, or is it going to be updated to Lux? Ah, it's Lux again. So what happened there? Because we updated team, but team is not the array. Team is just a reference to the original array, which is players. So when you edit that original array, or when you update any of the arrays, it's always going to go back to the reference where it was, which is not the same as what we did here with numbers, strings, and booleans. So that's interesting. If you update an array, it will always reference back. And that's what I find people do is I just want to make a copy of the array and update it. So what we then need to do is make a copy rather than a actual reference. And there's a couple of ways that you can make a copy of an array. You say const team2 equals, and you can take the players and just call slice against it. And if you call slice players.slice, that is just going to return the entire array, because generally what slice does is you ask for 2 and 3, and then it will give you one of them, whereas the original array is untouched, right? But what slice will do if you pass it nothing is it will take a copy of the actual array here. Let me just comment out this changing of the array. So let's take a look. We got players, and we have team 2. And if I were to change team 2 to Lux, team 2 has Lux in it, but players still has Poppy because we made a copy of it with our array. Another way you can see people do it is if we make a team 3, you take a blank array and you concatenate in the existing array, and that will just concatenate all of the items from that player's array into the empty array here. That'll work the exact same way. And then finally, we can use the ES6 spread way, which looks like this. Const team 3 or 4 equals, you create a new array and you spread into that array with the players. And what a spread will do is it will take every item out of your iterable and put it into the containing, in this case, it's the containing array, although we have also used spread to spread into a function as well. So that will take a copy of it just as well. Team 4, the last one, is going to be equal to and console log team 4. You see the last one, but if I go back to my players array, it's untouched. And then finally, we could say const team 5 is equal to array dot from, and then you pass it your players array. And if we were to look at team 5, that's our array, and we were to change one of them, then players array untouched, whereas team 5 has been updated. So a whole bunch of different ways. Array.from and the spread is probably my favorite way, but any of these ways will work just fine. Now, the same thing happens for objects as well. If I have a person object here and I want to make a copy of it, you cannot do this. Const captain equals person. Because if you change the captain's number to 99, so person is now 99, even though person should be 80, and we just update the number to 99, we just made a copy, we made a reference to the original one. So how do you take a copy instead? That is with something called object.assign. So you say object.assign. The way that it works is you start with a blank object. You pass it the object you wish to copy all the properties from, which is person. And then you sort of fold in your new properties that you wish to overwrite, which is number is going to be 99. And then you stick that entire thing in your own const cap2 equals, stick it into its own variable. Now when we console log cap2, you'll see we have, I got to comment these ones out here, 99. However, if I go back to person, the number has not been added to that one at all. So we just added them in. Same goes if I wanted to have a number of 99 in age of 12. The captain is now 12, but the person is 80. So what happened there is we take a blank object, we overwrite, or we sort of fold in all of the properties and values from our object, and then we use the third argument to fold in our own ones. We are going to be getting, or hopefully it's not confirmed yet, but we will be getting a cap3, which is called an object spread. And you may be used to this if you've ever done any React before, and it's ... person. And that works exactly the same way as we spread into an array, but you can spread into an object. Now, one thing that we do need to know is this is very shallow, meaning that it will only ever go one level deep. So if we create a new object here, so const Wes equals, say name is Wes, age is 100, and maybe we'll say social, and Twitter is equal to @WesBoss, and Facebook is equal to wesboss.developer. Okay, good. Then I've got this object here, Wes. Let's pop a quick console.clear above it, so we clear out whatever's in here. Oh, obviously this is not going to work, ... Why? Because object spread is not in JavaScript yet, so we have to comment that out. There we go. So we've got this object here. That's the person. You open up social, and we have the object there. Now, if I want to make a copy of Wes, we would say const dev equals object.assign. We take a blank object, and you pass in Wes, as we have here. Good. So I have dev. That's good. Dev.name equals Wesley. Now, Wes is still Wes, and dev is Wesley. So you see how we took a copy of that object, and when we update it, it's not going to update the original one, so it's not a reference. However, what if we do this? Dev.social.twitter is equal to @coolman. Now dev.social, the Twitter is there. But what if I look at wes.social now? Oh shit. Look what happened. Because when you use object.assign, it only does one level deep. If you need to go do a clone, you have to get out a function and go online and find it where it's called clone deep. And that will clone every level as deep as you want. Although before you do that, you should ask yourself, do I really actually need to do this? maybe I could be doing it in a better spot, because very rarely do you actually need to clone an object that deep. So we have that. And then another sort of cheating way, like the poor man's deep clone, and I'm not recommending this, but you could say const dev2 equals json.parse json.stringify, and you pass it your person. And now we have dev2. And then we say dev2.social.twitter equals @coolman. And now if we look at west.social, it has not been touched. Why? Because what you can do is you can take json.stringify and pass it an object, and that will return to a string. That's no longer an object. And then you immediately json.parse it to turn it back into an object, and then you get a full copy of it and you shake all the references. I have no idea about performance with that. You might want to look it up before you use it, but it's often referred to as the poor man's deep clone. Other than that, hopefully you learned a thing or two about object references and array references versus actually copying them. See you tomorrow.